Welcome back, my dear students. I'm your chemistry teacher. So, in this video, we are going to learn about few common topics like electronic configurations, Euler's diagram, and chemical bonds, etc. Let's get started without making it late. If you like my explanation, please subscribe to my channel and hit the like button. Let's see afterwards. Okay, now, yes, now as I said, coming to our video, you have to know about general electronic configuration before you understand anything about symbols and formulas in um symbols and formulas in our periodic table. Okay, so general electronic configuration is based on the shells and subshells which are there in an atom and where electrons are presented. So, electronic configuration is where we represent how many electrons fit in a particular shell. And then in the shell we have subshells and then orbitals. We are gonna clearly learn about them right now. Okay, configuration. Right now, please excuse me for my handwriting. I'm sorry. I'll increase the thickness. Yes, thank you. 3F. Okay. Now, everyone must know this thing. I mean, I'm telling it's a common thing, so everyone must know. Here, we have nucleus in an atom. We have nucleus in an atom where protons and neutrons are there, right? And then you have orbits or shells around the atom where electrons revolve around, right? Sorry, give me a second. Sorry. Uh, yes. So now each shell is given a number. Each shell is given a number where there is a particular number of electrons which can accommodate. Right? Now, example in first shell, only 2 electrons can accommodate. In second shell, um, 8 electrons may accommodate. In third shell, uh, 3 square, yeah, 18 electrons may accommodate. Okay. Now, how do I know this? By the formula 2n square. I hope you have known this. 2 is here, n is the number of shell. So, if you want to calculate for 2, 2 square, 2 square 4, 4 2s are 8. So, 8 electrons. Clear like that. By the formula 2n square. That is for shells. But today we are going to focus on general. So, we'll go with subshells. So, shells and subshells is not hard. Shells to everyone. Subshells we have. Okay, first shells means you have KLMN shells, right? Subshells you have SPDF subshells. In SPDF subshells, you have orbitals where the electrons originally are presented. Okay, now SPDF subshells. In these subshells, in the first subshell, 2 electrons may fit. Means there is one orbital. Means in one orbital, 2 electrons fit. This resemble an electron in the motion of clockwise direction, and this represents the motion of an electron in anti-clockwise direction. Okay, so that is what I'm trying to tell you guys. So there are 2 electrons. Now in P we have 6 electrons. P subshell means we have 3 orbitals. 3 orbitals. In D you have 10 electrons. Means we have 5 orbitals. Am I right? This became 4, 5. So each orbital contains 2 electrons, as I told before. Clear? Then F contains 14 electrons. Now tell me, guys, how many orbitals are there? Yes, we have 7 orbitals. 1, 2, 3, 4. Okay, the 4, 5, 6, 7. Okay. So these are the electrons present. So 2, 2, 2, 2. Okay, like this. Now I hope you're clear with the in an atom, right? Now all of these are arranged. So in first subshell, subshell में you have 1 is 2. 2 is the number of electrons which can be there. Okay, 1 is 2. Only 2 electrons in first shell. Then we have 2s2, 2s2 and 2p6 in second shell. Subshells. These are subshells, and how many electrons can fit in it? 2s2. After 2s2, you have 3s2, 3p6, and 3d10. Clear? And then you have 4s2, 4s2, 4p6, 4d10, and 4f14. Okay. Then after that, you have 5s2, 5p6, 5d10, and 5f14. Then you have 6s2, 6p6, and 6d10. Then we have 7s2, 7p6, and then at last we have 8s2. Clear? So this is the way in each shell it is there. Now I'll represent it by another color so you'll understand. 1 second. Give me a second. Okay. Okay. Yes. Now, hope this clarifies our doubts. Now, in first orbital, there is 1s2. In second orbital, you have 2s2. In third orbital, you have 2p6 and 3s2. Okay. In fourth orbital, you have 3p6 and 4s2. In fifth orbital, you have 3d10, 4p6. Once again, 3d10, 4p6, and 5s2. In 1, 2, 3, 4, 5. Sixth orbital, you have 4d10, 5p6, 6s2. Sixth orbital, you have 4f14, 5d10, 6p6, and 7s2. In fifth orbital, you have 5f14 and this like this. Clear? This is how it is. Now, based on this, we write the order of how electrons are arranged. Clear? From greater to big. Now, you must know that the whole Moella's diagram, this is Moella's diagram, okay, guys? Now, is based on n plus L value. Now, n plus L value is nothing but principal quantum number and some other quantum number, okay? Now, n is nothing but the number of subshell which you are there in. SP, DF, में which one? Okay? So, to calculate the n plus L values, you must know that this is to basically define the energy. How much energy does each orbital contain? Now, I'll show you how is that calculated also. Yes, give me a second. Now, this is an important one. See, there are, for L values, I'll give you the values, but we'll learn about principal quantum number and all afterwards. So now, for now, just remember the values. S is equals to 0. I'll write here, okay? S is equals to 0. P is equals to 1. D is equals to 2. And F is equals to 3. Okay, these are the L values. Now to know the n value is nothing but the number which is there, the shell number. Okay. Now this is to represent the order. They don't mean they're in shell. Okay, the one which I gave are in shells. Now, yes, n plus L value in the sense n here is 1. So 1 plus S is 0. So 1 plus 0 is 1. So 1 is the n plus L value energy. 2s2. 2 plus S is equals to 0 is equal to 2. So you got 2. Then 2p6. P is equals to 3, right? Sorry, P is equals to 1. So you got 3. Like that, you have energy levels increasing. They increase, go on increasing. Clear? Now, based on this n plus L values, we will calculate or write the order of how do you write electronic configuration. Okay. Now we'll first write the order. Then we will try a few examples. Okay. Sorry, give me a second. Something opened up. Yes. This is n plus L value. Now, okay. Now we will see how we can, uh, you know, write the order. Just a second. Uh, yeah. Now I've changed the pen color and pen. One second. There's an internet connection issue. Yeah. Sorry. Yeah, it's coming. Just a second. So, uh, yes, sorry for the disturbance. Now let's get started. I mean, continue. So, coming from here, it goes on like this. Okay, again, it goes like this. Now, coming to the order, 1 is 2 is lesser than 2 is 2. 2 is 2 is lesser than 2p6. 2p6 is lesser than 3 is 2. 3 is 2 is lesser than 3p6. 3p6 is less, sorry. Yeah, 3p6 is lesser than 4s2. 4s2 is lesser than 3d10. And 3d10 is lesser than 5s2. 5s2 is lesser than 5. Sorry, give me a second, not 5p6. It's a problem. Yeah, 5 is 2, then 5 is 2, after 5 is 2, what do you have? 4d10, right? So 4d10, 4d10 is lesser than 5p6, and 5p6 is lesser than 6s2. 6s2 is lesser than 4f14, then 4f14 is lesser than 5d10, then 5d10 is lesser than 6p6, 6p6 is lesser than 7s2, then 7s2 is lesser than 5f14, and 5f14 is lesser than 6d10. Then 6d10 is lesser than 7p6. And at last, after 7p6, 8s2. Done. So with this is the order. Very important. Now, one more thing. Do you know that all of this, if you combine all of this whole electronic configuration, it is the electronic configuration for 120th element, which is not discovered yet currently, but yeah. Okay. Now, let me erase this. A second, please. Mm, yes. So I'll just increase the size. Yeah. I'll quickly erase this, and now we will see how to write electronic configuration as we have the order with us. You just have to remember the Moeller diagram. You don't even have to remember the orders, because if you remember the diagram, you can do it on your own. Okay. Now, just a second. Let's continue with an example. Okay. Yeah. Now, with an example, let's continue. Example, you take chlorine. Chlorine is 17, am I right? If chlorine is 17, that does mean that we have 17 electrons. If we have 17 electrons, we go with like this. 1s2, 2s2, 2p6, then 3s2, 3p6. Then what have we done until? We are done of 10, 11, 12. We have 18. We should get one less, means 3p5. Okay, 3p5. Just a second. This thing doesn't. Yeah. Uh, yeah. 3p5. Now, after this, if you want to know, do you know that valence electrons and valency are all right? So to find valence electrons, this is 1s in first shell, this is a second shell, this is third shell. So you have 7 valence electrons. Do you know that 7 valence electrons? So you can tell the valency of chlorine is 1. Am I right? So also the Lewis dot symbol for chlorine is 1, 2, 3, 4, 5, 6, 7. Clear? Okay. Now this is an example to show you guys. So as we are done with molars diagram, electronic configuration, and the basic things to understand, we will see the types of bonds. Okay. We will see the types of bonds. Okay. Now before going to the types of bonds, I have a small topic to discuss, which is about ions. It's a small flow chart, which we don't have much to learn. Just about cations and anions. As we know, positively charged ions are called as cations, and negatively charged ions are called as anions, right? Again, both of these are divided into simple and complex cations and anions. Sorry, simple, complex. Clear? Give me a second. Yes, now simple ions, they contain only one atom. Now, example, Na plus or Mg2 plus, etc. Coming to complex ions, we have 2 or more NH4 plus 1 or H3O plus 1, okay, etc. Same for simple ions, sorry, for anions also same. We have simple and complex. Examples, we have fluorine. Here we have O2 minus or SO3 2 minus, or we have, sorry, this doesn't come here, O2 minus and N minus 3. Okay, this is the example. Now, now, so I guess we'll stop it here today. In my next video, part 2 of this session, we're going to learn about chemical bonds. Okay, bye for now, guys. If you like my explanation, please subscribe to my channel.